Stephanie's question is, when reviewing job descriptions, there is often mention experience building data pipelines. Is that referring to the entire process, or where does that fit within Hadoop ecosystem? Okay, so when we say data pipeline, basically you will learn this part as we go forward. Okay, when we are talking about Flume or we are talking about Kafka, when we do that, you will have a thought clarity on what does it mean by data pipeline. All right, wonderful questions. Any other questions? Did I miss anybody's question? Let me go through the. All right. Okay, so let me start with this particular point, that could you give a brief summary of the component we discussed last session, just a 2-minute summary. Of course, let me try that. All right. All right, just give me a second. Somebody is trying to log in and they're not able to log in. Just give me a second because looks like. All right, let me try to send today's link. I think somebody is struggling with it. Okay, so I am. I'm just trying to send the link to some people who are not able to join again, and let's see if that works. All right, I think that's pretty much. All right, so before we start today's session, I would like to just go over what we have learned so far. All right, so what we have learned so far is what does it mean by big data? Then we talked about variety, distributed computing, characteristics, and then we talked about whether a particular problem is a big data problem or not. And then we talked about why is big data important. And then we'll talk about the problems associated with the hardware. And then we talked about few examples of big data. All right. And and then we talked about the various big data solutions. Afterwards, we talked about overview of Hadoop. All right, so a quick overview again. So this is a typical ecosystem of Hadoop. All right, Hadoop was started with three components: the file system, HBase, and MapReduce. Rest of the components evolved later on. Okay, so the most important component is the file system. Just like in your computer, when you start it, the most important thing is the drive in which you keep the data, in which you keep the data in the form of in C colon, D colon, and the file system basically. Similarly, on the Hadoop, the most important component is the file system, because every other component tries to keep data inside HDFS. All right. The next is HBase. Before that is actually Yarn. Yarn is kind of an operating system that makes it possible to execute things in a network. Okay, we will understand in detail how does Yarn work, because Yarn is quite significantly important for understanding the process of Spark. Then we talk about HBase. So the HBase is basically a NoSQL database, and it makes it possible to store data in the form of table. And specifically, if you have to update a lot of rows, a lot of columns, or a lot of cells very frequently, then HBase is very, very useful. In case of file system, as we all know, that if we have to modify even a single line, we have to rewrite the whole file. But that's not the case with HBase. All right. So HBase is the NoSQL data store. Now, since we cannot, it's very tedious to write program for Yarn. So people have come up with various framework that makes life easier to distribute the work on many computers. Such frameworks are MapReduce and Spark. So half of the course, less than half actually, goes into MapReduce, goes into the typical Hadoop ecosystem. Rest will be dedicated to Spark. All right. So approximately half of the course is dedicated to Spark, and rest is for these components. Then we have Hive, which is SQL interface to MapReduce. Okay, because the way if you have to modify a database, if you have to search for something using a usual program like writing for loop, writing the Java code or C code, C++ code, it will be very tedious to do simple operations like joining two tables, right? Using the usual programming language. Therefore, SQL is required, and Hive is a component where you write your logic in SQL that get converted into MapReduce, and that gets executed on Yarn. All right. Similar is the case with Pigletin. You write Pigletin to churn your data, and then Pigletin converts that into MapReduce, executes it into on Yarn, and gets the result. Then we have machine learning library called Mahout. Okay, it contains the functions related to machine learning, and it contains the functions related to the statistics or statistical inference. All right. Then we have the data import export tool called Flume and Scoop. So Flume is for continuously importing all kinds of data onto the cluster, say HDFS and Hive and HBase. And Scoop is for copying the structured data, okay, in batch-wise fashion. So Scoop internally calls MapReduce, and that MapReduce pulls the data to the cluster. All right. So this is what the ecosystem looks like. All right. Batra's question is, can you tell the difference between Hive and Pig? Okay. Can you tell the difference between Hive and Pig? So Hive and Pig are very similar. Pig basically is a simplified SQL, far more simplified SQL, and is basically designed specifically for distributed computing. Okay. But mostly you will be using Hive mostly. Pig we should understand, and we will learn very good key concepts such as lazy loading and others while learning Pig. Okay. All right. Now, I think we will talk about this part at later point of time. Okay. I think it'll be better to talk about this part at later point of time. Let's not talk about it now. Okay. Because it doesn't make sense to talk about the faults of MapReduce before learning MapReduce. Okay. Or faults of the existing system without learning the existing system. Okay, so we'll talk about this part maybe at a later point of time. Okay, the later this part actually where we are discussing about the overview of Spark. Thomas, right? We'll talk about it once we are through with the basics. All right. So I want to do two things in this session. Okay, I want to do two things. One, I would love to have the introductions. Do you think it's a good idea to have, say, 30 seconds introduction from each? Okay. By the way, 30 second for each means 12 minutes. I hope that should be okay. And second thing I want to do is I want everybody to log in along with me onto the cluster. All right. Yes, Jiten, this is Hadoop 2.0. Hardly anybody is using Hadoop 1.0. It's not 2.0, it's actually 2.7 or something. Okay, 2.6 or 7. We'll see that. All right. Do you think having introductions, I mean, voice introductions is a good idea? All right. Okay, so I'll start from the top. So Karthik, you can unmute yourself and tell us about yourself, and that'll be good. Yes. Hi, Karthik. You can unmute yourself and give a brief introduction if possible.
Hello, are you able to hear me?
Yes, I can hear you.
Yeah, hi Sandeep, this is Karthik here, and I'm currently working as a project manager with an IT company. I have an experience of around 13 years, and I've been mainly into Microsoft technologies and cloud Azure. I just want to get into big data technologies and see like what's happening there, and maybe shift into big data also, big data projects.
Wonderful, wonderful. Great to know you, Karthik. And I'm happy to have you in the session and proud to know
Thanks.
that you have a great experience. We'll all enrich from experience. All right.
Thanks.
Good, good. And the next one is administrator. I'm not sure it is showing administrator. Should I unmute you or you will unmute yourself and introduce? Yes. All right. All right. Ali, you can go forth and yeah, unmute yourself and introduce yourself. Yes, Ali. Okay, no worries. So you can introduce using chat. Arslan, you will be comfortable in unmuting yourself and introducing yourself?
Yeah, sure, Sandeep. Hi, everyone. My name is Arslan Sajid, and I'm from Canada. I have almost 12 years of experience. Basically, I'm working in databases, data warehousing, and informatica. So I have a development experience. So in all these technologies. Thank
Wonderful. Wonderful. Thank you, Aslan. Barsa, do you want to go ahead?
Yeah, hi, this is Varsha. I have around 10 years of experience into Java JT.
Mhm. All right. Great to know you, Barsa. Sapna, do you want to go ahead?
Hello.
Yes, yes, I can hear you.
Yeah, you can hear me. Hi, everybody. I'm Sapna, currently based in Canada, and I have more than 15 years of experience on Power Builder and Oracle. So currently, I'm looking for a career change. So that is why I'm interested in learning data.
All right. Thank you, Sapna and
Thank you.
Barsa. Great to have you in session, Barsa and Sapna and Aslan. All right. Jamil, you want to unmute yourself and go ahead?
Yeah, can you hear me?
Yes, I can hear you.
Hi, my name is Jamil. I'm from UK.
Mhm.
I
We kind of lost you there. Hi, Jamil. We kind of lost you. Jitendra, you want to go ahead next? All right. Are you able to hear me? Because it got muted suddenly, and I thought, okay. So, Jamil, I missed your introduction.
okay. Let me do it again.
Yeah, please, please. Yeah.
Yeah, my name is Jamil. I'm from UK. I have more than 15 years of experience in Java J2E technologies. I'm already a Cloudera certified Hadoop developer, and I'm just here to learn Spark. That's the reason I'm here.
Okay. Okay.
Thank you.
Great. Great, Jamil. Then you can help the other candidates with respect to the Cloudera certificate questions. Great.
Definitely. Yeah.
Great to have you in this session, Jamil. All right. Jitendra, you want to unmute and go ahead?
Hi, can you hear me?
Yes, I can hear you.
Yeah. So basically, I'm Jitendra Jain. I'm currently based in Singapore. Overall, I have about 17 years of experience working in support and development.
Mm-hmm.
Recently, I have certified myself in AWS at the associate level for solution architect developer as well as the SOPs. And now I'm going ahead with the Hadoop so that I can make a career change.
Great. Great to have
Thank you.
you in the session, Jiten. All right. Karthik, you want to go ahead? And after Karthik, Batra can go ahead.
Yeah. Hi everyone. This is Kush Batra, and I am from Canada. Currently working as a senior developer and have around 7 years of experience in Java J2E technologies, and looking forward to work in big data technologies going forward. That's why I'm here. Thank you, everyone.
Wonderful, wonderful. Manjunath, you want to go ahead? And then Mohit after Manjunath.
Yeah, can you hear me?
Yes, I can hear you.
Yeah, I'm working as a Java developer.
Mhm.
I have around 6+ of years experience, mostly on Java and JTW technologies. I'm a certified MongoDB and Cassandra developer. We are basically exploring more on NoSQL database. Currently, just came across some kind of very large file of data. Just wanted to explore how exactly we can use big data components in our project.
Wonderful, wonderful. Great to have you in the class.
Thank you.
Mohit, do you want to go ahead?
Sure. Hi everyone, this is Mohit Agarwal. I am working as analytics manager for Max Life Insurance. I have approximately 7.5 years of experience. I feel big data is one of the key ingredients in all the business problem solving that is going to be in years to come. And with all the technologies merging, the data is going to explode. And management of this data, it's a key skill that one needs to have in the repertoire. That is why I'm here in this class.
Wonderful, wonderful. Nada, do you want to go ahead? Wonderful. Great to
Hello,
have you.
hello, can you hear me?
Yes, I can hear you.
This is Nada. I live in senior Oracle developer and fearless girl. Honestly, I'm enjoying it and I'm looking forward to go back to the data with the new technology that we I believe it's the future of everything.
We could not get you, Nada. The voice quality was bad. Okay.
Okay, okay, thank you.
All right. So I think it'll be great if you could just type because we could not understand anything. Did anybody else understood? Because okay, okay, all right. No worry. So Nada, could you just write? I would love to know you, and I would definitely love to know you. And okay, Nitin, do you want to go ahead, please?
Hear me?
Yes, but it's very feeble.
Yeah. Can you hear me now?
Yes.
Hi everyone. My name is Nitin. I'm from US and I'm a graduate student. I want to build my career in big data. That's why I've enrolled with this course. Also, I'm looking to work on some project in my final semester. Hope this course helps me.
Great, great. Sure, sure. Great to have you, Nitin, in the session. And yeah,
Same, yes.
all right.
Thank you.
Okay, Omkar, you want to go ahead next? And then Prasant.
Hi, can you hear me?
Yes, I can hear you.
Yeah, hi. I'm Omkar Sabnis, and I'm also from US. I'm a graduate student as well, and I'm a beginner in big data. I have no knowledge as such in big data. I also want to build my career in big data.
Wonderful, wonderful. Sure, we'll definitely help you. And Prasant, do you want to go ahead now?
Yeah, sure. Hey everyone, can you hear me?
Yes.
Yeah. Hey. So I'm Prashant Kumar, and I have kind of 13 plus years of overall experience, primarily working in ETL data warehousing technologies in finance domain. Currently, I'm based out of New York, New Jersey, and right now I wanted to have this course because I want to explore big data and NoSQL databases and how they can be leveraged in finance and security domain.
Wonderful, wonderful. All right, great to have you in the session. Priyank, do you want to go ahead next? Priya?
Hello.
Yes.
Are you able to hear me?
Yes.
Yeah, this is Priya. I'm from Bangalore. I work in networking industry for around 12 years now, and I'd like to have a career shift towards the big data and join this course so that I can check out how I'll be able to do that.
Wonderful, wonderful.
But also I have another thing. I have no experience in Java or scripting. I'm just a C and a C++ candidate. So I really want to know how to do this.
You will be able to handle it because in one of the sessions we will take you through Scala basics, and that should be good enough to get you up and running with Scala, and that should be very useful for you to switch the career. All right, and
Okay.
right, Ramana, you want to go ahead? Great to have you in the session, Priya. And Ramana, you want to mute and unmute and go ahead, please? Wonderful. Okay. Sapna, do you want to go ahead? All right. So Ramana does not have a mic, and okay. So Ramana is from Dubai and has 15 years of experience in Microsoft technology and want to change the career. All right. Wonderful to have you in the session, Ramana. All right. We look forward a great interaction with all of you. Sapna, do you want to go ahead, please? Okay. Sapna has done the introduction. Yes. Saptrishi, you want to go ahead?
Hi, Sandeep. Can you hear me?
Yes.
Yeah, hi. Hey, everyone. Thanks for the opportunity. This is Saptarishi. I have around 10 years of experience in application development, but currently I'm working out of the New Jersey, New York area as a production support specialist. I have been, my whole career has been, I have been working in for hospitality and travel clients.
Okay.
And I have never worked in an ETL or a data warehousing environment. I've always worked in the real-time OLTP environment, and I'm currently interested in shifting, exploring the other side of it also. So that's why I'm here. Thanks.
Wonderful, wonderful. Thank you, Saptarshi. Sheikh, do you want to go ahead?
Yeah, hi everyone. Can you hear me?
Yes, I can hear you.
Yeah, my name is Sheikh and I'm from Dubai. Yeah, I work along with Ramana. So yeah, I also have around 11 years of experience in total in Microsoft technologies and would like to learn big data for a career change.
Great, great to have you in the session. All right. Mishra, do you want to go ahead? Mishra, we can't hear you.
I think you named me.
Yes.
My name is Subha, and I have around 13 years of experience in networking and virtualization. So, just I want to understand how this new technology. I just want to understand and what is the pros and cons.
Great, great to have you in the session, Shubh. All right. I look forward for a great interaction. Stephanie, you want to go ahead?
Hello, everyone. I'm Stephanie. I'm from New York. Currently, I'm working as a support engineer, and I'm taking this class because I'm interested in just learning more about the big data related technologies.
Great. Great to have you in the session, Stephanie. I look forward for great interaction. Sundar, you want to go ahead?
Sure. Are you able to hear me?
Yes.
All right. Hello, everyone. Sundar, based out of Houston, Texas, US. 18 plus years of experience in IT industry, out of which 14 plus years in data warehousing, both managing and architecting. I would like to be involved, glad to be here in this course, and I also would like to know more about big data side without getting involved with the Java. And I also need to know how big data can fit in very much in oil and healthcare industries.
Wonderful, wonderful.
Thank you.
Great. All right. Ed, do you want to go ahead? All right, Dad, I can't hear you. Yes. All right. Is anybody able to hear Dad? Because I'm not able to hear. All right. All right. Thomas, you want to go ahead?
Hi everyone, I hope you can hear me.
Yes, I can hear.
Okay, I'm Thomas from Germany, Berlin, and I'm a software developer for 18 years. Starting with J2EE, I built some POS systems and ERP systems, and a lot of reporting stuff on Postgres. Then the last 5 years, I worked as freelance developer for different companies and moved to Python, MongoDB, and full stack JavaScript. And currently, I'm setting up a team for a new startup in the healthcare industry, and I encountered some limits, which I hope to solve with big data and machine learning. That's why I take this class.
All right, great, wonderful to know you, Thomas, and I look forward to learn from you as well. All right, and Thomas, do you want to? Sorry, Ted, do you want to try again once more, if that's not possible? All right, we can't hear you again. All right, no worries. It'll be great if you could, yeah. So business background shifted to IT, wonderful in 2000. Wow, 12 plus years of experience in J2E, 8 plus years experience in integration, and currently 6 plus years in healthcare system. Wow. So I'm just actually wowed by the backgrounds of the candidates in the session, and there is definitely a lot to learn from each other. And after delivering around 1,300 hours of the session, I find myself to be in a better position to answer people's questions, and I've learned a lot because of the sessions. Other than working on various kind of projects, this has been great learning for me, and I look forward for a great interaction. My classes are known for basically able to answer the questions and have a great interaction in the class. So make sure that we keep the class lively, and I'll also try my best to keep everybody awake. All right. Okay, so now enough of theory. So today we are going to log in into CloudX Lab. All right. So let's quickly take a look at the CloudX Lab credentials. Everybody can see this section in the course page. All right. All right. So, all right, go ahead then. Okay. If any of you get stuck and is not able to proceed, please let me know so that I'll make you the presenter and will guide you through it. And why would I do that? Because that will help others as well. Okay, so let's open Ambari. Okay, just I'm asking to just log in once so that, okay, Prasant does not see a course page. All right. Prasant, can you just type in the email ID? Okay. Privately or in public, it's okay to share it in the class. Yeah, I'll just quickly try to fix it. If I can fix it, that'll be good. Okay. All right. So you open Ambari and try to copy paste the login from here and the password and log in into Ambari. Okay, everyone. And once you're done, you should be able to sign in. Everybody is able to log in. So you can see there is HDFS. There are 6 out of 8 nodes started, and so on. Okay. All right. Just give me a second, Prashant. I'm taking a look. All right. Good. Prashant, you should be, you refresh the page, it should be there now. Okay. All right. So everybody is able to log in into Ambari. So Ambari shows us the status of our cluster. It shows that there is, yeah. So Ambari is kind of an administrator console. Okay. So what is Ambari? Basically, when I installed Hadoop, the way I installed is I first installed Ambari agent, Ambari server actually on one machine, a.cloudxlab.com. On that machine, I installed Ambari, and then I added the network. I added the host into it, and Ambari is the one who has done the installation of our cluster. Okay, so that we don't have to install each and everything. All right. So if you are planning to install install Hortonworks or Hadoop, Ambari is a very good choice. Okay, all you have, because all of the headache of installation is actually absorbed by Ambari. Okay, so that's the starting point of your cluster. We have already done it. We have right now, it shows that there are 7 nodes, 7 data nodes. One is dead, and so on. Although it's showing like 6 out of 8 has started. And these are the services being installed by Ambari itself. Okay, all of the cluster is installed by Ambari. Okay, these services we have shut down because these are not required. Accumulo is not required. Okay, we have also installed Spark. This is the old Spark, but we have also installed newer Spark in the cluster. Okay, so this is a quick overview of the network. You can see that there are these many hosts connected: 1, 2, 3, 4, 5, 6, 7, 8. One of the hosts we have shut down purposefully. These 2 hosts we have shut down purposefully because they are not required right now, and we will run them when it is required. So question from Karthik is Ambari. So Ambari is a provisioning tool. You can say it's an installation tool. It helps us install Hadoop. Okay. So Barsa is saying that I do not see the lab. Email ID is Barsa Sastri. Okay, just a second. So for you, this part is not visible, Barsa? Or the whole page is not visible?
Whole page is not visible.
Okay, okay. All right. All right. So let me fix that one for you in a minute. And all right. So a question from Sundar. Okay. Okay. Question from Sundar is, yeah, can we learn to install how to install these using Ambari? Yes, actually, it's pretty straightforward, and I have provided the documentation in session 1. Okay. In the session 1, we have provided a documentation already, and it should be okay. So I'll show you. So here in the session 1, you see there are installation instructions here. Using Ambari, I have provided the instruction here. You can take a look at this one. Sometimes, okay, sometimes sometimes you may want to install a virtual machine. It's not really needed for the classes. But if you really want to install a virtual machine, what is a virtual machine? So what people did was people installed Hadoop on one machine, and then they created a virtual machine out of that one machine, so that you do not have to install any other thing other than downloading a virtual machine and running the virtual machine. Okay, so we have provided how to set up on your desktop. This documentation details that part. All right, so you can take a look at it, and it also gives us various ways of connecting to the cluster. So Tad's question is Ambari feasible for local dev environment? Yes, it's actually possible. Hortonwork installation that you will do here, that will contain Ambari in it. Okay. Question from Arslan. So is it the interface which we are going to have on job, or it can be different? So it can be slightly different. You don't have to generally interact with Ambari. If you are into administration role, and the company where you're joining, there you are using Hortonworks, then Ambari will be used. Okay, so we will be mostly interacting in this class either with Hive, not Hive, Hue, or the console. All right. Okay. So, all right. So just a second. I think I missed a few questions. A question from Jamil is, does the node need full root permission for Ambari to install the Hadoop components? Yes. Okay. Yes, they do. All right, because you should have the sudo permission. Sudo means ability to execute something as root. Karthik is saying that, so if we are working on real-time project in a company, they'll use Ambari tool. Some of them, yes. Okay, but Ambari is not that useful. It's mostly to look at the administration side. So if you are a Hadoop administrator, you will be using Ambari. It can be different, Arslan. Okay, and all right. Priya is saying I am on the Mac and I'm on the app and is not able to log in. I'm unable to get into any page. The app is not allowing me to move out of app page. Which one are we talking, Priya?
Sandeep, I try to move out of it and then get into any Google Chrome or Safari, anything. I just check any page or log into any notepad or something. It still comes back to the same app that is used for doing the video. And I'm just not logged into anything actually.
I see.
So I don't know it's a Mac system problem or presently I can't log into anything.
Is it? Okay.
Do you know of the problem or should I
No,
just go ahead?
I'm not aware of this problem. Okay.
Okay. Okay.
Yes. Right. So, all right. So, Jitan's question is, so Ambari is from Hortonworks. Yes. Okay. Mishra is not able to log in into Ambari. Does it give login incorrect? So Jamil is sorry. So could you restart your computer, Priya? Maybe there's something wrong with it. Okay. All right. Thank you, Jamil. And so question from Karthik is, so any company will have Ambari, Hue, and console for admin purpose? Yes. Console would be there, as in, instead of a web console, you will get SSH. All right. All right. So Mishra, one thing you can do is you can try copy pasting. Okay. You can try copy pasting. There is there could be an extra space. Thank you, Ted. Thank you to figure that out. Okay, because when you select this, right, sometimes we basically select one extra space. So copy pasting should work. All right. So 2, 3 users. One is okay. So there was one more person. I think Barsa was not able to log in. So Barsa, I have given you the permission. Okay, I have given you the permission, and I mean you should. I mean I checked the role, and you are having the role, so you should be able to see that under my courses. So you can go ahead again and say my courses, and it should show you this course. Okay. Sorry. All right. So you can, under my courses, you should be able to see your credentials here. Or you're not able to log in into No Big Data. You don't have your login password.
I'm able to log in, but it doesn't show the core lab.
This section is not there.
Yes, sir.
Okay.
What is the parent of this? From where you come?
So when you,
Or
yeah, I gave you the link. If you click on my courses, okay. If you click on my courses, you should see all your courses, because I'm a member of many courses. I see many courses here. You should see this particular one. Do you see this particular one?
oh, yes.
Okay, and then click on it. And inside that, this should load the CloudX tab. All right. So this is one. Next is okay. All right. So next is that you can go to CloudX Lab as well. Once you have logged in into the No Big Data, if you go to CloudX Lab, you will be automatically logged in there with your email ID. If you're not, you can log in using the same email ID and it should work. Now here, there is a Learn tab where we keep on posting the hands-on, small hands-on video on how to do this, how to do that. That should be quite useful. Okay, so you can take a look at that part as well. All right. Also, it has some more things like IP mapping, settings, and all that. Okay, so that's about the lab details. Okay, so Barsa is able to do. Priya is not, and who else is stuck? Mishra is not able to log in, right? Okay. All right. Let's go ahead with the second part. We will try to fix it as we go ahead. And all right. So there. So that was Ambari that we talked about. Second is Hue. Okay. Yes, I mean, generating new password will take a little bit time, Mishra. Okay, so we will send you after the session. All right, and we can go through it again. All right, so this is Hue. So earlier we talked about Ambari. Ambari provides an administration interface. If you are trying to install a Hadoop cluster and you are okay with using Hortonworks, probably starting with Ambari would be a great choice. We earlier tried with Cloudera installer, but that was too proprietary. That was one reason why we moved away. Second, the installer wasn't really great. It always ended up with many unmanageable issues. Okay, so that's why we moved to Ambari now. But The extra tools that Cloudera has provided is Hue. Hue is a very wonderful product that Cloudera has built and is quite useful for many things. Okay, it's quite useful for many things. I'll show you. So here in this, you have interfaces for Hive, Pig, Impala, and Uzi. Along with that, we have HBase, Zookeeper, and various kinds of other tools, including file browser and job browsers. Okay, so this is what you see right now in the file browser. This is the HDFS. This is the Hadoop file system. Okay, this is Hadoop file system. This is my home folder that you see here, user Sandeep Giri 9034. Okay, and at the top level, you will find a data folder here at the top level, /data we call it. Here, all of the data related to the current class is available. All right. Jamil's question is there an installation document for Cloudera Hue to be installed within Hortonworks? We haven't, we have actually tweaked the installation. We have done a lot of work on making it run on Hortonworks. So that we have not made it public. Okay. We will make it public soon once it's in good shape. All right. We'll be sharing it with the students. All right. Next is, so this is the data folder that will be you will be interacting. The data that you will require for. All right. So question from Sundar is, how did you go to Hue link? So one is that you just go here, click on Hue, provide your login password, and then you will see all these menu items. Along with that, there is a file browser. In case you do not see a file browser, just use this. Okay, just use this. No, you cannot go from Ambari. You will have to go to No Big Data and then try. All right. Or you can just open a new tab, and in that tab, you would just type this URL or copy paste it, or just click on this URL. Okay, so once you are there, you can click on the file browser, and the file browser basically has this. In case you are not seeing the file browser, sometimes for some of the systems, it doesn't show here. In those cases, you can simply type file browser in the URL, append file browser, and that should be good. Okay, so this is HDFS. This is Hadoop file system. Okay, all right. And if you go at the top, and then go into data, this is where you will find our data sets related to the course. And if you are interested in more data sets, you will find in this folder. This is the Enron's email archive. This is some of the data sets from Coursera, okay, and some of the data sets that will be required for Spark streaming. Okay, this is a project which we have done recently for some of our customers. Okay, so you can try that data set as well, and we have provided detailed instructions on CloudX Labs blog. Okay, so we keep on working on CloudX Labs things so that we keep on providing all our students updated content. Okay, so a few things to. Yes. So one is this, and let me just go up. All right. So other is this. Good. Question from Manjunath is that there is nothing inside the data folder. Actually, you must have clicked the data twice. Okay, you might have gone into this folder. All right. If you go up, you should see the same data. It's a read-only data. You don't have access to change it. All right, Manjunath, you are able to see the data. All right, good. So this was Hue. So go up to, I'll say this. If you go here at the top, you can just say view/data. Okay. Yes, you should be able to see. All right, you have to go to the top level and then click on the data. Don't click on home. Home is your directory. This is my directory. This is my own data that I keep on generating during the classes. Okay, so your folder will be empty. Okay, click on the slash. You see the slash here? Thank you, Prashant. And then you click on the data. Don't click on data twice. This data folder, we are going to remove it. Okay, wonderful. Manjunath, you are able to see that? No? Great, wonderful. So everybody able to log in into Ambari and Hue? Okay, all right. Let me ask you in a different way. Who is stuck in Ambari or Hue? Mishra? Mishra is the only one, I think. So your login is also not working in Hue? All right, all right. Could you just copy paste your email ID? If I can quickly solve the issue, okay, I will do it right away. Okay. So Priya, what kind of issue are you facing?
Hello. I logged into the CloudX URL that you gave me, and I am logging in with the same No Big Data's user mail Gmail account and the password that is
Okay.
provided. I'm unable to log in. It just fails.
Okay.
Um,
Okay. You're not able to log in using that. Okay. Just let me try to. Okay. All right. Shubh, I'm going to delete your user. So you will have to refresh. You will have to refresh the enrollment and it will be created again. Okay. So you go to No Big Data and then try again. Right. You refresh your No Big Data space, Shubh, and that should be good. Yes, that's correct, Saptarishi. Your CloudX Lab login details are different from your No Big Data details. Okay.
oh, it is different.
Yes,
Hello.
yes, yes.
And where is it provided?
If you go into your No Big Data here, do you see login password here?
Just hold on.
Can you share your screen? Okay.
1 second. Okay. And okay, now I get it. Because earlier I was stuck with things, so I missed this.
Okay. Okay. No worries. No worries. Wonderful. Wonderful. You try it out and then let us know. Okay.
Yeah.
Okay.
Okay.
All right. All right. Great. So, all right. So I think everybody will be able to. Okay. All right. So, yeah. All right. So, Sapna, that's not a problem. And if you don't see any data, it's okay. Can you please show my, yeah. So if you, once you have logged in into No Big Data, once you logged in into No Big Data, and then you go into CloudX Lab, okay, CloudX Lab here, and click on, say, My Lab, you will be already logged in. Most likely, you will see your login here. And when you click on My Lab, you will see all the details. Okay, so there are two places to look for your login. One, in the No Big Data's course page, along with the CloudX Labs MyLab. All right, so we have built it in such a way that no matter where the user has logged in, whether, because CloudX Lab is a central platform for many learning companies, including Simplilearn and other. So when they come to into their learning management system, they automatically log in into CloudX Lab. Okay, that's the way we have built it. All right, now coming back to where we were. Sundar's question is, under data, we have folders like Flume, Hive. So these are the folders that contain data which will be used when we interact with Flume or Hive. Okay? So that's how it is. All right, wonderful. Great set of class. And probably everybody is able to log in. All right, now let's move ahead. Next thing we should do is, Mishra, are you able to see the login password this time, or what do you see in the CloudX Lab session? Here?
Sandeep, I can see the new setup password, but
Okay.
it's giving the same error.
Okay. Could you privately share your login and password with me so that I can take a look?
Okay, fine.
Yeah. In case the copy paste is not working, try clicking on show password and try typing it. Thank you, Jamil. Yes, sometimes your Windows may not be allowing the copy password, and that could be another reason. All right, so you might try to type in. Okay, now moving ahead. All right, so try clicking on show password, see the password, and then then you type it. Okay, now moving ahead, and the third thing that we are going to spend a lot of time is the web console. Okay, so what is web console? I'm going to take out this tab and I'll make it a little smaller so that we can see what is there on the screen. All right, do you see? Now, here, I'm going to log in into the console. All right, so I'm logged in into this console. It's the Unix computer. We have basically created your accounts on using Unix computers. So yes, you can use PuTTY as well. You can use PuTTY as well instead of the web browser. In PuTTY, make sure that you say e.cloudxlab and also provide your this login. So in there, you will have to say this. Okay. All right. So here I clicked on Web Console. It opened a new tab. There I provided my login password. All right. All right. So in another tab, I'm going to use to open. Okay. All right. Mishra, are you able to, when you type this, are you able to get into it? In the beginning, it's 1, not L. Okay. It's 1, not L, because in your font, it might be looking like L in your password. All right. Okay. So, all right. So everybody is with me. Okay, so let me try to see if I can log in into the Hue using the password. Okay, so I'm going to use Shubham's login password. Okay, and here is your password, Shubham, and sign in. So see, I'm able to log in. Most likely it's a problem of copy pasting. Okay, so I'm able to log in. Most likely it's a problem of copy pasting with you. All right. Okay, so here I go. All right. So the most important part is that these terminal URLs are different. Yes, thank you, Jamil, to inform. So yes, for everybody, for some it'll be E, for some it'll be F, some it'll be G. Okay, and we keep on adding more terminals as and when we have more demand. Okay, so we have kind of load balance these machines so that if we all are logged in into a single machine, okay, if we are logged in into a single machine, that means that particular machine will may not function correctly. Okay, so right now what you see here is that when we say that we are logged in into console, it means we are actually kind of physically on this machine. We can do anything that anybody can do on this machine. Okay, so when I say ls, it is showing me the list of my files. No, so whatever URL has been assigned to you, that's the one you have to use. Okay, so your login may not work in F or E. Okay, so for some it'll be e.cloudxlab, some it'll be F, it'll be G, and we have done it so that everybody is able to log in. Okay, that's how we manage. So where do we find this URL? You go into here in your CloudX Lab details. There'll be there'll be a button called Web Console. Click on the Web Console button and it will open here. Okay, provide your login password there, copy paste it, and you'll be okay. So who is not able to log in into console? Yes. Everybody is able to log in into console. Manjunath is able to log in. Thomas is able to log in. Wonderful. Wonderful. Great. So this is the place where we'll be spending a lot of time. So we will get ourselves acquainted. So Karthik is not able to log in. Okay. So, all right. Yes, you can either copy paste the password. Yeah. So when you paste the password or type the password, it will show nothing on the screen. So do not worry, because in Unix, when you type a password, it doesn't show asterisks. It basically does not echo anything. All right. In Unix, when you type password, it does not show anything on the screen. So do not worry and go ahead and type your password or paste your password. You will be able to use. All right. Okay, so Karthik and Nada. Who else is stuck? Mishra, are you able to? Mishra, Priya, Barsa, are you able to? Good, good. Priya is able to do. Okay. All right. Nada, for Nada, it's working now. Karthik? Wonderful. So I wanted to, everybody to be with us because I do not want to keep a separate tutorial classes. Okay. Because I do not want to build this attitude that in the theory classes we cannot practice. Okay, the whole class is about hands-on. So we'll be doing a lot of things together, and so we need to get it working. It's only the first day that we face this kind of problem. So Karthik, just can you click on the screen share, and we can take a look at your share, your screen. Okay. And how do I stop sharing? Stop recording is there. I've paused the sharing. Okay, I've stopped sharing now. You can share, please. Karthik. Yes. Okay, you can hide your password actually. Okay, no, just click on copy, please. Click on copy because you're going to copy extra space. So when you are clicking on f.cloudxlab, okay, paste, Control V, yes, enter, go to the previous window, copy, paste, Control V, enter. It is pasted, yeah. Okay, good. All right, wonderful. So you are able to log in. Everybody is able to log in. Great. All right. So that's how we get to the terminal. Okay. So some of you who are on Mac or Linux computers, they can simply say SSH, their login name. Okay. Their login name. Those who are on Unix computers, they can do this. And the host name. This is the host name. Okay. This is the host name. So I picked up the host name from the browser. Okay. And my login name, as then I'm saying SSH, my login at host name. Okay. I'm doing it from my terminal. If you are on Linux or Mac, you can do the same thing. Because by default in Mac and Linux, the client for SSH is available. SSH is a protocol by the way of which we can execute any command on a remote machine. Okay, so this is the same shell, same command prompt, what you see here in the browser. Okay, wonderful. So now, since we all are logged in, now is a good time to start with the basics of a Linux introduction. So how many of you want a quick introduction, like 2 minutes introduction on Linux? Yes? All right. Okay. So Tad and Ali and Manjunath, except for 3, everybody is okay with Linux introduction. Okay, I'll just try to go through the quickly over. Arslan is also good. All right, so but I'll go ahead because I think the other number of people are more than 20. Okay, so we'll try to go through very basics so that we all get comfortable with the Linux. All right. So in Unix, everything is a file. Let's understand this. The root directory is called /. You can create a directory within a directory. You can put a file inside a directory. Okay, so the file system as we see in the Unix is a kind of a tree structure, starting with slash. Slash is by default the root folder under which everything else comes in. So you can keep directory within directory within directory and so on. All right, and you can put files inside a directory in the same way what we have in file browser on Windows. Okay, there are few special directories in Unix. For example, /proc keeps information about processes. /etc, etc is a folder in the top level directory, okay, where we keep configuration. Temp/tmp keeps temporary data. /home keeps the directory of all the users. Okay, so you can refer a file either by relative location, such as dot means a directory at one level above. Okay, all right. So either you can say go up one directory, then go into Sandeep, then go into XYZ here, like this, or you could say uh, absolute, such as /tmp. Files have permissions. You cannot change the slash data, for example. Okay. So what is command prompt? It's a place to execute any command in the Unix. Okay. A command is a file which is executed on the prompt in the following manner. Command followed by arguments. And when you run a command, it is loaded into the memory and becomes the process. Okay. All right. So a command prompt is a place to execute commands. All right. Now, so we'll interact with this a bit. Okay. Thank you, Anup. Thank you, Ted, for answering the question. All right. Okay. So we are using CentOS. We are using CentOS, and okay. All right. I'm going to just take you through the first command which I'm going to use is pwd. It is showing me my present working directory. Okay, CentOS is a flavor of Linux, which is also used in Red Hat. Okay, so CentOS is a flavor of Linux. All right, so pwd is my present working directory. Whenever I'm on console, you are in a directory. Okay, and you can know that by typing pwd. Okay, if I want to go up one level, I can say ct dot dot. All right, so now my present working directory is /home. All right, I can go back to my home directory by just typing cd command. All right, and then to see what's there in my current folder, I can say ls-l. It is showing me so many files because I have created so many files. All right. For you, it may not show you all these files. Okay, so I'm using pwd ls. All right, so if I want to directly change my directory to a particular directory, I can say give their absolute name. I've said go to the top level, and under which there is a folder called /tmp. So my current directory is /tmp. Slash means top level. When I say pwd here, it is showing me this, and when I say ls-l, it is showing me the list of all the files in the /tmp folder. Good. So you can see there are quite a few folders in this one. All right. Now, if you want to see who all are logged in into e.cloudxlab, you can see we have some users logged in right now. Okay, around 10-15 users logged in. All right, so you can see that there are quite a few users who are logged in. Good. Now, you can basically see what all processes are running using PS. PTS is the name of terminal. Okay, every user gets a terminal, and that's the number of the terminal. Okay, so if you type TTY, it will tell you which one is your current terminal. If I open one more console, it'll give me another console. Good. So that's about it. So that's the basic of it. If you want to say create a new file, you could use nano my file, and here you could type something and it'll create a new file. Okay, you could create it'll create a new file. Okay, nano is an editor which is simpler, although there are quite a few editors like vi, but nano is a good editor using which you can edit a text file or create a fresh new file. In case you want to upload data directly into this, you can upload using file browser. Also, there's a difference between HDFS and this particular folder. Okay, when I say ls, it is showing me the file which are there in my directory in e.cloudxlab, not in HDFS. Okay, keep that in mind. All right, so that's good for starting with cloudxlab. All right, we will go into more details about HDFS and other things as we proceed further. Okay, so that's kind of a very fast or very quick introduction to Linux. If you have questions, I would love to answer it. Okay, if you want to get more details on Linux, you may want to go through this particular session here. I have given a little bit more detailed example of Linux. All right. Okay, so Sundar, you can press Control and X. Okay, this caret character and X means Control and X both, not capital but small. All right. Did it work? All right, wonderful. Great. So now let's go ahead with our usual discussion on HDFS today, and then we will go ahead with the yarn. All right, so I'm going to skip a lot of details about HDFS, which are not really too much required for this course, and I'll try to focus on the important areas. All right, so let's take a break for 10 minutes and then we will start our discussion on HDFS. Okay, so far we have been able to get up and running, have the introduction with the class, and are able to log in into CloudXLab. All right, so let me increase the font. Break for 10 minutes. Back by 9:43 p.m. IST. Actually 44. Somebody has to translate it for me. Okay. Sapna, could you drop me an email about this? I will make a note of it. I'll just put this into do. All right. Yes. So break for 10 minutes and we'll be back by 9:44. All right, so I'm back. Should we start now? Yes. Okay. All right, so we're going to discuss a very important component called Hadoop distributed file system. And unlike the traditional way to jump into the component and try to understand, we are going to first understand why do we require a new file system. File systems have been around for quite since the beginning of the computer. The file system has been there. Since the beginning of an operating system, file system has been there. Okay, so why do we need a new file system? That's a very important aspect. Why would we throw away all the knowledge that we learned and start with a new file system? Okay, now here's a question for all of you. And yes, I hope it's recording. Yes, it's recording. All right, here's a question for you. Let's say you have to store 100 terabyte of data. How would you store it? How would you usually build a storage of 100 terabyte data? Imagine that you are in a college and all of you decided to share your data or movies, or build a storage where you can put all of your movies and share with all your friends and so on. So you have to say build a storage of 100 terabyte. What is it that you will do? Yes, good, Jitin. All right, great set of questions. Multiple hard drives and load balancing. Good. And yes. All right, Nada, it's okay to share. Share your question with everyone. All right. Nada's point is that we need a server TP provide ultimate control. Yes. Ali is suggesting RAID. Wonderful. So yes, so you have basically answered what I was looking for. All right, typically I'm talking about say 2002. This is how we built our storage at Disha when we had to store so much of data. This is what we did. What we did was we added hard drives into many computers. We added big hard disks into many computers, and then we connected those computers in the network, and then we mounted these drives in some of the computers and told everybody that, hey, here is the folder from which you can access our data. This particular folder contains this kind of data. This particular folder contains this kind of data. This data is divided into these many folders, and so on. Okay, so and on top of it, what we did was we created backup of each hard drive on every machine. Backup of every hard drive on every machine. Now, question to you is, do you see any problems with this kind of model? Yes? Do you see any problems with this kind of storage? So this was a typical way of creating massive storage. All you have to do is put hard disks into the computers, connect the computers into the network, and then mount these hard drives or map these hard drives into one of the folders as a subfolder. Every hard drive is becomes a folder under a main folder. Okay, all right, all right. So Jitin's Kush says that availability is a problem, while Jiten is saying the users would need to know which disk to approach. Brilliant. Network latency issues, yes, excellent. Seek says if one drive fails, then whole chunk of 1 TB of data becomes inaccessible. Yes. Priya says accessibility path, that's correct. All right. In case of disk failure, you lose data. That's correct. And if server's main folder gets corrupted, then that's another issue. Yes. All right. Karthik says failure of data. Brilliant, brilliant. You have answered all the questions that are looking for. Yes, those are the right question. Thomas says the logical chunks are not the same size is a problem. Correct. Okay. Yes. All right. So in those kind of models where we have these computers spread across, okay, there's always a problem of failovers and backups. Okay, there are two things. One is failover and another is data recovery or backup. Okay, so in most of the systems, we cared about creating a backup system, backup of the data or having a recovery plan. But failover was important. Failover means that in case one of the computer goes down, then we should have another computer to take its place. But in the current model that you saw previously, in the current model that you saw previously here, right? In case the network connectivity of any of these computers goes down, the data is inaccessible. There is no failover, although there is a backup. Next is, how would you distribute data uniformly? And the way Kush has put it is that storing data in optimized manner can be tricky, and accessibility is always a challenge. Earlier Mishra has said. So yeah, so basically it's very difficult to distribute data uniformly. Do you remember when you had like 2-3 hard disks and you were trying to store movies? You always get stuck whether I should keep music in one drive and or movies in another. But then if you put the movies in one drive, that drive is empty, and the one which contains movies is always full. So you always get stuck in this kind of non-uniform distribution of data. Some of the disks become full and some of the disks remain empty. And that is another challenge. Now, the third problem that you would see this kind of models is this the best value for money? Okay, is this the best use of resources? We might have hundreds of smaller hard disks available. If you put more smaller hard disks, it will lead to more unmanageability in this case, right? Therefore, we do not get the greatest value. Okay. And next question is, what about increasing accessibility? Imagine this. Imagine this. Today is Independence Day, and everybody wants to watch um, some kind of patriotic movie which everybody would like to watch on that day. Now, that movie is in a folder stored on a hard disk. And in case everybody wants to watch it at the similar time, then the machine that contains that movie, or the hard disk that contains that particular movie, patriotic movie which everybody wants to watch it today, will get thrashed, will get overloaded. That particular machine will get overloaded, and eventually it might crash and nobody might able to watch it. Okay, so that bottleneck of accessibility is there, right? Next is scaling out, meaning today you want to store 100 terabyte of data. What happens when when you want to store 150 terabyte of data? How easy it is to distribute and update the existing system and so on? It is not. Right now, you'll have to make the change plans, as in move this folder to here, move this data. So all of that is manual. All right. So these are the problems that we face using a traditional file system. Okay. And that's where we come up with Hadoop distributed file system. This is where Hadoop distribution file system comes into play. All right. So here we go. Now, how will this kind of problems that we have discussed, this kind of problem that we have discussed, how will these problems get addressed by HDFS? Let's take a look at it. Keep the challenges in mind and try to challenge HDFS on these problems. Try to see if HDFS really caters to these kind of problems. Then you will get the idea. You'll get the idea. You'll get the idea that why HDFS is designed in that way. All right. Let's take a look at how does it work. All right. So as some of you would have thought that if you have to build 100 terabyte of storage, we will keep an index of what is where, maybe on a whiteboard, maybe in an email and inform everybody about it, or maybe in an HTML page, or maybe we'll build a small service which will keep track of which movie is in which machine, right? So with exactly same thought, HDFS has been designed such that there is one node that keeps the information of what is where, and that node is called admin node. All right, before I jump into all of this thing, so when I say node or when I say machine, okay, it means a process, it means a service that is going to run. Admin node, data node, all of these things are a service. So there is a machine on which we are running admin node, and then there are many other machines on which we are running data nodes. Okay. All right. So all right. So one of the machine is dedicated to keeping the metadata, while other machines are keeping the actual data. And what does it mean by metadata? Metadata means what is where. Okay, what is where and who has permission on what. All right, so this is admin node. Admin node keeps the index of what is where. It has metadata. This is called metadata. It is a service, meaning what is a service? When you run a program, there are two kinds of programs. One, when you run it, it gives the output and shuts down. Those are called batch-wise execution. You run a program, it executes certain things, and then shuts down after giving you the output. Such kind of processes or execution is called batch-wise, right? And there are another kind of process which keep running all the time, which keep running all the time. For example, a mail server keeps on running in the background of your server. Mail server is a process that keeps running in the background and keep answering to the email requests. Okay. Similarly, a web server keeps running in the background of your computer. Of a web server is keeps on running in the background of your web server where you have hosted your website. It keeps running in the background and answering to the questions. Okay, and most of these services, they have this model called the model is that they they expose a port number. They expose a port number just like a ticket counter on a railway platform where you have every ticket counter is numbered. Okay, that this is the window number 1, window number 2, window number 3. Similarly, every program which is running in the background attaches itself to a port. Okay, for example, a web server, when you're running, it generally attaches itself to, who can answer that? All right, you could not hear. Can you hear now? Ouch. Looks like there's a hardware button on my headphone. Okay, all right, let me see. All right, yes, so till what point did you understand? Yeah, let me try to explain what does it mean by batch wise. Okay, batch wise as in the batch. Okay, so in an operating system, there are some commands like the way we ran ls. It gave you the output and shut down, right? Let me show you. So when we say ls, it ran and shut down, finished. It gave you the output. Its work got finished, right? While the command like top, it keeps running in the background. It is running continuously, monitoring. Okay, so these are the two general ways of execution of a program, right? Now, some of the programs, when they run, they attach themselves to a network port so that they can serve to the network request when people on another machine or the same machine can talk to the process and get the output. Say for example, say for example, uh, say for example, the web server. Okay, who can tell me that the web server attaches to which port? Wonderful, wonderful. So when a program runs, it attaches itself, when a service runs specifically, it attaches itself to a port, and where on this port, on this number, on the window number, the the people or the processes can connect. It's like a, so uh, when a program is run, specifically the web services or any kind of service which runs continuously and responds to people, it attaches itself to a port, and every program attaches to a port. Okay, we'll see that. Now, question to all is like, okay, similar to web service, email also runs as a service in the background. Email service will keep on running, and people will talk to the email service and drop the email or read the email. Okay, so email service runs on which port? Quickly, who can answer? Wonderful, wonderful, great, great. So yes, it runs on 25 port. All right. In the similar way, in the similar way, in the similar way, admin node runs as a process, attaches itself to a port. Okay, we'll talk about which port number in a while. All right. It attaches itself to a port on which people talk to it. Okay, on which all other processes talk to it. All right. So all of these things, whatever blocks you see, whatever block you see here, it is it is a service that's running. Okay, so there are two kinds of nodes that build the HDFS. One is called admin node, others are called data nodes. Admin node is only singular because it keeps the metadata, it keeps the information that needs to be singular. Okay, there cannot be two admin nodes running parallelly and making modifications to the file system. Okay, therefore admin node has to be singular. Okay, admin node has to be singular. Then yes, Prasant, I'll answer that. Now there are data nodes that keep the actual file, so let's move on with the data nodes. All right, so what does data node contain? Data node contains the actual data. Data node contain the actual data, and they don't contain the actual data in the as such. When a file is stored, it is cut into pieces, and those pieces are stored on these data nodes. So the files are split into the chunk of 128 megabytes in case of Hortonworks. In case you're using Cloudera, the default size of chunk is 64 MB. Okay, but this can be configured. It is up to you how you configure the chunk size. Okay, when you cut the file into these blocks, okay, it helps us fitting very huge file onto small disks. That's the first advantage. Second, it leaves less unused space on the disk, right? Because the maximum unused space on a disk would be around less than 128 MB, correct? So therefore, it helps us fit big files into small disks and leaves less unused space. Similarly, when we will notice this later on, that it optimizes the data transfer. All right, it optimizes the data transfer. It distributes the load onto multiple machines. So when you try to store a file on HDFS, first it is first the information is updated at admin node, and then the data is put into data nodes. All right, now the story does not end here. Every block is replicated. Every block is replicated onto multiple machines. All right, every block by default is copied on 3 different machines. By default, every block has 3 copies, and so that in case one of the machine that contains actual data dies, the data gets recovered from other machines. Okay, all right, so I think I missed a part. So a file is cut into blocks. Okay, a file is cut into blocks, and by default the block size is 128 MB. You can change the block size. Let's say you have a file containing a file of size 130 MB. Okay, so there'll be 2 blocks. One First block will be 128 MB in size, and second block will be 2 MB in size. Okay, if you have a 130 MB file. All right. So if a data node fails, the lost blocks are recovered and the replication factor is maintained. Okay, the moment you lose a machine, all the blocks that are lost, now their replication, their copies are not 3 anymore, their copies are less than 3, right? There'll be 2. So HDFS will automatically try to recover that lost block by again creating the third copy from existing copies. Okay, so that's how continuously that's how it continuously balances the data nodes. Okay, so that we can have a great failover, we can have a great backup. So that's the idea behind replication factor. And the question is, why 3? Why not 2? Right? Why not 1? Okay, so all right, I think there are quite a few questions that I need to answer. Ted, was I able to answer your question? And Manjunath, can we configure like 90 MB? Yes, you can configure that. Okay. Aslan's question is, okay, yeah, thank you, Aslan. And yes, a good question from Priya. Now, a very good, often people ask this question that when you have 3 replication factor, aren't we losing too much of storage? Okay. Yes, we are losing too much of storage. But when you have such a cluster and you are adding all kinds of nodes in a cluster, when you are adding all kinds of node in a cluster, the storage is individually is not costly because it is so generally the HDFS is huge array, and therefore it's not the actual storage that's costly, it's your data that's costly, and therefore it's okay to have 3 copies. Sometimes when you have a huge reliability on your hard disk, let's say you're using SSD and you are sure that nothing is going to happen to your data, in those cases you may opt for a replication factor less than 3. Okay, you can opt for a replication factor of 1, but then in case one node goes down, remember this part, in case one node goes down, all the blocks that are there on this machine will get lost, which means all the files which these blocks belong to, all those files are corrupted because these blocks might belong to many files, right? So losing a single data node could make your entire file system defunct. Why? In case you do not have a good replication factor. Okay, if you have a replication factor of 1, remember all the blocks on a particular node will get lost. Not all the files only on that data node. No, all the blocks and these blocks could belong to all the files, right? Therefore, it's very important to understand that losing a block is far bigger damage than losing in a usual way, right? Because if you lose one piece of a file, the whole file is corrupted. Although the other blocks are available of the same file, but they're of no use anymore, right? So That's one of the reasons why we have a default replication factor of 3, which is more than 2, right? Because the damage that each data node loss would cause is really high. Therefore, we do not want to take a risk. The probability of losing 3 data node is very low. A question from Thomas: do you still need other nightly backup or replication? Replication is safe enough. Saptarishi's question is, do all data node need to have same storage capacity? No. Unlike the cousins, the distant cousins of HDFS called RAID 5, for example, there all the disks need to be of the same size. Otherwise, if they're not of the same size, the only data that it can store is equal to the smallest of all the disks. Okay, so there, but in this case, it is, in case of HDFS, all the nodes could contain any kind of disk. Okay, and some of the nodes can also in a Hadoop cluster, some of the node can decide not to participate in in the admin in the HDFS. All right, very good question from Kush. I think I would love to answer. Okay, anybody wants to answer this question? These are very important questions. Same with Arslan. Okay. Good, good. So question is, if there is a one huge data file, let's say of 10 GB. Quickly, how many blocks will 10 GB have? Blocks in 10 GB? Yes, how much is that? All right, it'll be 80. Thank you, Ramana and Prasant. All right, so if you have, let's say, 10 gigabyte file and you have distributed it you have put it into HDFS, and internally, first admin node made a note of all the file name and file size and so on, and then we distributed that file, they cut those 10 gigabyte file into 80 blocks and distributed 80 blocks onto these 4 nodes, and then those 80 blocks will be copied thrice, which means by default it'll be 80 into 3, which is 240 total blocks. Now, question is that when we need the whole file, don't you think it's too much of headache to gather all of this data and concatenate and build the entire file? Answer is yes, it is. Therefore, when we deal with big data, we try not to do that. We never try to retrieve the whole file and then do the processing. Instead, we build mechanisms so that individual block of data can be processed on every node where it is found, right? Since the blocks are on many machines parallelly, if we can process individual block on those machines, that will be wonderful, right? There's no need of transfer data or concatenating data and so on. Like, for example, we never put a zip compressed file in HDFS. If you have a file, you put it in other kind of formats called LZO. Okay, so that when you recover your data, you do not need entire data to be copied to one node and then unzip it. Do I make sense to you, Kush? So we never try to do that. It is going to be time consuming. All right. Next question from Aslan is, how does it split the file into chunks? Is there a specific criteria or it is just random? If it's random, don't you think it's a problem when we are going to pull it? All right. It's a ruthless cutting of the file. Okay. Whether the boundary of 128th MB is in the middle of block, in the middle of line, in the middle of character, or in the middle of multi-byte characters. So it doesn't matter to HDFS where is the boundary. It'll just cut it exactly at 128th byte or whatever is your configuration. All right. Correct, Arslan. So question is, since the data is distributed, how are we going to aggregate? And that's where the tools come into play. So that's where Hadoop clients, Hadoop file system client, HDFS client come into the play. These clients are the libraries, okay, that do the magic of splitting the data, joining the data when we retrieve or upload. Okay. Now, a question from Saptarishi is, all right. Question from Saptarishi is, if a file is in two blocks, in two nodes, and we need to read the file, does it make more sense to read block 1 from node 1 and replica of block 2 from node 2 itself? Yes. So generally what people do is there are many optimizations that are needed at various places. Okay, so let's say you have two blocks. One is data node 1 and another is data node 2, meaning machine 2 and machine 3 in this particular case. And let us say that you want to concatenate data. You want the data to be concatenated, and that's what you want. So what you do is, what the clients do is, they read data parallelly from both the nodes. They read data parallelly from both the nodes, and hence it becomes faster to read data from HBFS. It becomes really fast to read data because you're reading data from two nodes parallelly, not in sequence, right? Therefore, many kinds of magical optimizations are possible. Okay. Sometimes if your file is having, let's say, 8 blocks, these 8 blocks are on 8 different computers, and when you try to access these 8 blocks parallelly, the overall speed you will get is around 1/8. Overall speed you get is 8 times, okay, because you are reading 8 hard disks parallelly. The only bottleneck will be the network in these cases. Now, question from Mishra is, when user is going to access the data, which data from node, from 3 replicated node will get preference? We'll get into this. It's a very interesting question, Mishra. So we'll get into this, and you will get the importance of this question as we go forward. All right. Question from Brad: when processing data in parallel across multiple nodes, at which point is it aggregated? Okay. So very important question. Question is, when we are processing data, at which point it gets aggregated? The answer is, it depends on us. It depends on the developers. And that's why we have this humongous class where we'll try to avoid concatenating, aggregating data as much as we can. All right. And best engineer would not need to aggregate data ever. Okay, because if you try to aggregate data, you are going back to a single node kind of model. All right, and we will try our best not to do kind of aggregation of the whole data and overflow a single node. Okay, because imagine that you have 5 terabyte of file. Can you actually download that file out of HDFS? No, because your local machine from which it will get copied may not have that much of space, right? Therefore we avoid it. And these are very profound questions, and as we go forward we'll try to address it, and that's the whole agenda. All right, are you able to hear now? Okay, so as we go forward in this class, we'll try to answer your questions related to the aggregated part. Okay, so yeah, so because the better the developer you are, the rare would it be that you will try to bring the data back to a node. Okay, imagine that you have 5 terabyte file. 5 terabyte file means how many blocks? Quickly, 5 terabyte means 1 GB means 8 blocks. Okay, so it will be 5 into 8 into 1024. Those many blocks. So you cannot really copy 5 terabyte because you generally don't have that much space on a single computer, and therefore it doesn't make any sense. All right, good, good. It wasn't 45, it was 5. All right, now another very important aspect, the way we visualize, being from architecture, I always visualize HDFS of this format, meaning there'll be a user who will talk to name node. Name node will gather all the data and give it back to the user. The answer is no. This is not the way name node handles the user request. Okay, the way instead it happens is user uses a client or a driver. User uses a kind of a command or a library to talk to HDFS, and that library talks to both. Okay, yeah, this one has no. No. All right. Where is the arrow? All right, let me try it. Okay. Yeah, no, it's good. Sorry about it. Okay. Yeah. So instead, the communication is in this form. The user talks to name node or the whole system using okay. The user talks to the HDFS using something called a client or a driver, just like you use the JDBC driver or ODBC driver to talk to database. Similarly, the client uses a command to talk to HDFS. Now, this command, whenever you want to say create a file, first this command talks to name node, tells name node that, hey, I want to create a file, block a URL or block a file name for me. And then this client starts talking to the individual data node and stores the data there. Now you can see that this client driver can talk to multiple data node parallelly and store data parallelly. on all the data nodes. That means the performance of driver will be far better. Or similarly, if a user wants to read a file, if user wants to read a file, then user will tell the command that, hey, give me the file, and then that command will go to the name node, name node, and this command will ask name node that, can you tell me how many blocks are there, and can you tell me where are these blocks and their replica copies are there. And then client driver will go to those nodes and download that data directly. So you can see that the client driver is talking directly to the data nodes. All right. So that is why name node is not a bottleneck here, because name node is not used to route the whole data. Although name node continuously interacts with all the data nodes. Okay. So there are two questions. One is from Mohit. While processing on different blocks of a file, some of them will be on the same node. Will they still be processed in parallel? So if they are on same node, they can be processed in parallel, and that's where the optimization lies. In case of Spark, it uses multiple processes or threads in parallel to process these on the same node in a parallel, while in case of MapReduce, that was not the case. All right. So there were quite a few optimizations of this sort that have been done recently. All right. Next question from Sundar. How the reporting tools like Tableau access the data from HDFS data nodes? Good question. Will the performance go good? Yes. So all these tools, they generally they come at this level. They are the client or the driver of HDFS. Okay, they are the client or the driver of the HDFS. Make sense to you? Sapna's question is, can you explain the part again as to when client interacts with the data node directly? So let's say you want to read some data from HDFS. Let's say there is a file on HDFS. You want to read that file. So what you will do is you will instruct client or driver to read that file. The client will go to, client is a library, it's a software, right? It's a command, it's a program. This program goes to name node and says that, hey, can you give me the file? And then the name node gives the list of data nodes instead of giving the file. Name node gives the list of data node that contain the file. And once the client has those details, client goes to the data nodes, okay, directly, and start reading the blocks and concatenating those blocks and give you the result. All right. Yes, basically client slash driver aggregates or splits the results and gives the user the main point of abstraction. Okay. So yes, Sundar is saying that then the arrow should be both ways. That's right. Arrow should be both ways. This arrow should be both ways. Okay, let me make it both ways. Is there a way to make it both ways? There would be. I'll do that later. Okay. Here I'm trying to. Both the arrows 1 and 2 will be both the ways because it'll read the data, write the data. So the name node never directly reads or write anything to the data node. That's correct. That's correct. Even in the circumstances when one of the data node goes down, name node generally instructs data node to copy the data amongst themselves to recover the lost copy. Okay? Instead of name node reading the data, because so Sundar is saying that you say that command goes back from name node to client driver? Yes, that's right. So command talks to name node, gets a list of all the data nodes and the block IDs. Every block has got an ID, and then the client driver talks to the data node, asks for the data inside those block IDs, and client driver starts reading parallelly or sequentially. It's up to the client driver to decide. Okay, you could build your own client driver which could do the better optimization. Okay, so is the name node the same as admin node, or is it's the same thing? Okay, so yarn doesn't come into picture right now. Okay, so HDFS has no intervention of yarn. It has nothing to do with yarn. Yarn can be down and HDFS can be working perfectly fine. All right. Okay, a question from Manjunath. So we can say that map code runs on each data node and reduce runs on, no, actually, reduce also runs on data node. We will learn that part. Okay, we will learn that part. So it is very sure that, so no matter what code it is, nothing runs on client driver. Okay, and let's not talk about MapReduce right now because MapReduce has no role to play with respect to HDFS. Okay, we will understand it in a separate manner. Right, right. That's correct. I think I'll do that after that class. Thank you, Sundar. So when name node delegates the processing to data node now directly return results. Correct, correct. Yes, bypassing the name node. That's exactly what happens. All right. All right. Let me try to take you through the. All right. So this is a classic architecture. All right. So wonderful set of questions. Keep the questions coming because that's the only way to learn. All right. So in this architecture that you see here is the client is directly writing and reading the data into the data nodes. These are the data nodes. These are two clients, and this is the name node, or you can also say admin node. Okay, but I think name node is a better term to use. Name node contains metadata, as you can see. The metadata means the name of files, name of folder, all of that is metadata. Okay, name of file, name of folder, permissions, and so on is the metadata. Then we have the clients that are so client reads directly from the data nodes. Client also writes directly to the data node, and replication happen amongst the data nodes. You can see that the client will write first block here, second block here, then the replication will start amongst them, and so on. All right. The other operations on block are informed by the name node to the data nodes, and that keeps on happening. All right. So that's the way HDFS architecture looks like. The same architecture shown in different way. All right. All right. So there was one question about what happens in case of single point of failure. So my question to all of you is, should we start with a simple hands-on before we jump into more details about HDFS? Because I don't want to delay too much the hands-on part. Okay. So let's first, stick to our philosophy, a little theory and a little hands-on. All right, so everybody is in the console. Yes. Let's create a simple file. I'm going to call it, what's the date yesterday? 5 November. All right. And I'm going to just type some garbage here. This is just another file. Okay. So I used a command called nano, and I passed the new file that I want to create as argument. Okay. Using this command, I'm saying nano 5 November is like opening a notepad and saving that file in a file called 5 November. In Unix, it's not mandatory to have suffix. Okay. All right. If you want to check what's there in a file, you can always use a command called cat. So I'm seeing if there's something. Yes, there is something. Right now, this file is only in e.cloudxlab. Good? Yes. Now, is everybody able to create a file? Yes. So all I did was nano file and wrote something, press Control X, press Y, and then press enter. Okay. So all I did was type something here and then press Control X, saved it and pressed enter, and I have successfully created the file. Good. Anybody stuck? No. Right now, this file called 5 November, this file called 5 November is only in this machine called e.cloudxlab for me. For some of you, it'll be F or G. Right now, this file is located on this computer. It's not inside HDFS. Good? If you don't believe me, check the file browser, press home folder, go into the file browser here at the top right corner, click on file browser, click on home, and then look for the file called 5 November. It's not there. Okay? It's not there right now. Did you check? All right. So in the file browser, it's not there yet. Okay, you can try refreshing. Reason is because this file browser is HDFS, while this is local file of this machine called e.cloudxlab. e.cloudxlab or a.cloudxlab or all of these again, I'm jumping to say Ambari. So in this, you can see that there is one name node and there are these data nodes. Okay, there are 6 out of 8 data nodes alive and name node is up. Good. So right now when we are going to Hue, we are interacting with Hadoop HDFS, and when we are taking a look at it, this is HDFS and this is the local file system in the console, local of e.cloudxlab, because e.cloudxlab is node in itself. Therefore, this file is only local. Now, we will use a command called Hadoop fs. Okay, Hadoop fs is a way of interacting with HDFS. All right. If you want to see what all commands are supported by Hadoop file system, you can say Hadoop fs-help. Okay, Hadoop fs-help. It shows you all possible list of commands. And you can actually do everything using Hadoop FS. You can append to an existing file in HDFS. You can see a file in HDFS using Hadoop Cat. You can compute the checksum, the signature of a file called checksum, change the group, change the permission, and copy from local. This is the command which we are going to use. Okay, so we are going to say Hadoop FS copy from local 5 November. Okay, so by default, it would copy this file called 5 November from current directory to my home directory in HDFS. So 5 November got copied from this current directory, this present working directory called home slash Sandeep Giri 9034 into my HDFS directory. Notice that here it's slash home slash Sandeep Giri. Here it's slash user slash Sandeep Giri, right? So this is HDFS. You see, notice the difference. All right. Now let me try to refresh it and then see if the data has been copied. Now you can see there is 5 November file here. All right. So we have uploaded a local file from e.cloudxlab into HDFS. Good. All right. So when you say Hadoop fs minus ls, it is going to show the complete list of files. Okay. These are my list of files. In your case, it'll be only one file or maybe no file. Okay. So when you say Hadoop fs minus ls, this is what you see. It is showing the list of files in my home directory in HDFS. Good, everybody with me? All right. So one more thing, the most important part to notice is that this list shows you the information about the file, meaning what is the permission, who all can read, write, or execute a file. Second, this one is the replication factor. Okay, this one is the replication factor of the file. This is the name of the owner, this is the name of the group, and this is the actual size of file. Okay, so it's actually Hadoop fs minus ls. Okay, minus ls, please note. All right, so you can see that when we are doing ls, it's basically a single copy. All right, but it has the replication factor as 3. And you can see that last modified time. Now, Aslan says that can we see different copies? The quick answer is you are generally not allowed to do that. Okay, but let me see if we can try to do it. HDFS. So there's a command called HDFS. Okay, this is what we are going to use. Okay, so notice the URL of the file. It says slash user, then my login name, then 5 November. For your file, you have to provide your login name here. All right. So notice in the file, you might have to change my login to your login. Okay. So right now we have copied a file called 5 November. First, we created the file using Nano. We created a file called using Nano. Then we copied that file from local file to HDFS. Then we are trying to find out the number of copies. Okay, for that we are using another command called hdfs. hdfs fsck minus blocks minus locations minus recs and minus files. Okay, it shows you the detail about the file, the metadata associated with every file. Okay, so now you can see that. Okay, Sundar was able to answer your question. You can see that here it is saying that connecting to the name node, okay, via this URL. Okay, fsck was started by this particular user on this particular file, and here it says that there is a file called 5 November which is only containing 59 bytes. And since it's a very small file, there is only one single block. Okay, and here in the next line it shows you there is a block ID. You see the block ID, and then there's a block ID blk underscore da 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 and so on, right? Then it shows you that the replication factor is 3, and this is where the file is located. It shows you that it's located in this node, and this node. And what does this colon means? It means there is a data node that's running on this particular IP address at this particular port number. Okay. All right. Now, question is that if we increase the replication factor to something else, will this number change? Okay. Let's try to change the replication factor. And how do you generally change the replication factor? Take a look at Hadoop fs minus help. Okay, so let's take a look at. There are too many commands. I'm scrolling up. So I'm scrolling up, and do you see here? There is a command here called set replication factor. That's correct, Thomas. Yes, Hadoop fs set replication factor. Let's say I call for 6 copies of 5 November. Okay. By default, when I'm not specifying the URL, it will try to look for this file in my home directory. Okay. It says that replication factor set as 6. Now, first let's try to take a look at Hadoop fs minus ls, and I say 5 November. So you can see that the replication factor has been set as 6. Okay, now let's take a look at the replication actual status. All right, so you can see that the default replication factor is 3, and still there are only 3 copies, and there are 3 missing replicas, which means the process of replication is still going on. Okay, let's see what is the status now. Still, there are 3 missing copies. Probably it's taking a little while to get it done. Okay, it's taking a little while to start the replication. Okay, so still 3 missing copies. That's okay. Maybe after a while it will update it. Yes, thank you, Sundar, to remind me that. All right, I think I'll just do history. Okay, history command gives me the entire story of my today's day. Okay, we talked about up to this today. Yeah. Yes. All right. These are the commands that I had executed today. I hope that'll be okay, Sundar. All right. In case you want this file right away, I'll give you this file right away. Okay. Is it done? This is the 6th November one. All right. Here is the URL from the Google Drive. All right. Good. So this is what it is. Yes. So Ali is saying that although it's set in the metadata that total requested copies are 6, but it's showing basically when I say Hadoop FS minus LS, it shows that the promised replication factor, not the actual. Okay, it's still yet to copy, and I'm wondering what's wrong with this. Okay, let me take a look at it again. Hadoop FS minus LS. All right, so promised is 6. Maybe it'll take some time to kick in. So question is, Saptari's question is, can you show us once again where to locate the file in HDFS? So whenever you are interacting with HDFS, if you don't specify a location, by default, it's going to create this file in my home directory. Okay, if I go to my home, okay, if I go to my home, I should see this 5 November file in my home directory. Okay, this is what you meant, Saptarishi? So good point, Nitin. Thank you. So he changed the replication factor to 10, out of which 7 are done, 3 are still pending. Can somebody tell why is it so? Correct. Only 7 nodes are available, and that's why there cannot be 10 replication factor if there are only 7 nodes. Make sense? Because no two replicas of a block can exist on a single node. Okay, on a single data node. Yeah. So Sundar's question is, but there are only 6 active data nodes. Okay. I will say that, see, now it's saying 7 data nodes alive. So maybe somebody has restarted the 7 data nodes alive. Here, there is something wrong with these data nodes, and the reporting is wrong here. Okay, so there are actually 7 data nodes alive. You can see that. 8th one, we have purposefully killed it. This one, I think, it's node manager. Sorry, it's node manager. It's not the okay. Just again, there's something wrong here. It's not correct. Here, okay, so Karthik, you can see there are 7 nodes alive. Okay, a question was regarding if you can see the HDFS from Ambari. You can see there are something called views. Okay, you can create a view or something like this, and I'm not sure how do you change it. There was a way to do it. Okay, there was a way to do it, but I'm not sure how do you do it in Ambari. All right, but hue is sufficient in itself. And okay, Ali says that in my Ambari, in summary section, everything is stopped. How could that be? Okay. All right, I'll take a look at it. Maybe you were in Accumulo or something like that. All right, good, good. So everybody able to copy the data into HDFS and able to check the locations. Let me also see if my, wow, there is something seriously wrong with this. All right. Okay, I'll wait. I think it'll happen eventually. There may be something going on. All right. It'll take some time. For some user, it might happen. And since we are accessing it too frequently, maybe it's taking time for replication. All right, it's not done. Okay, so we were able to interact with HDFS, everyone. All right, so we will talk about how various arrangements, the advanced level of HDFS in the next session. In the meantime, try to attempt the quiz, try to do the hands-on try to copy, upload the data. Interestingly, you can directly upload the data into HDFS using upload here. Okay, take a look at this kind of documentation that we have provided here, installation instructions, and in the session 2 I have talked about the first one is the file system. Actually, there are 2-3 file system. You might easily get confused. So to explain that, I have written a small post. Yes. So Jamil, you can take a look at it here in, right? All right. Priya's question is the thing here is only once we copy using this, right? So this Hadoop FS is the guy who is called the driver, right? This Hadoop FS is the driver or the tool that will talk to name node, that will interact with data node and copy the data all onto all the locations. Okay, this command Hadoop FS will do that for you. Okay, Priya's question is only, okay, Priya's question is that only then allows for setting the replication. Why not before it for at the file, meaning before creating the file, if you have to set the replication factor, right? So there would be some option in the copy from local. Okay, while copy from local would be providing a way to set the default replication factor while uploading the file. Also, on the whole system, you can mark the replication factor so that by default, every file that gets created, instead of 3, they can get different replication factor. A question from Jamil. Is there any document to install Hue on Hottenwork? Sure. Let me take a look at this part. Let me put it in the to-do. Okay. Let me put it in to-do, and we'll share with you that one. Okay. Uh, all right. So yes. Yes, you can also do the installation on your local machine, but you won't be using it much. So you try doing the VM. That's not really mandatory, but more important than that is go through, let's say, second session's Cloud Lab explained. Try doing going through Hue hands-on and these things. Along with that, try going through the CloudX Labs, My Lab. Okay, there is a Learn tab there. Okay, there's a Learn tab where we talk about various things. Okay, various things. So let me see if we can bring Learn tab into our LMS. Okay, I'll try to do that so that you get the holistic experience of Cloud Lab, because we have tried creating small videos on how to do this, how to do that, like how to upload a file using WinSCP, connect to Web Console using PuTTY, and so on. Okay, so try going through this. If you get stuck, feel free to let me know. Okay, also all of you, okay, if you want um, one-on-one session, okay, drop me an email at reaches@nobigdata.com for okay with the 3 different time slots. Okay, so generally we provide one-on-one session. If you really are stuck and you need a help, then feel free to reach out to me at this. Just provide me with 3 different time slots so that I can fit it into my calendar. So we don't charge as such for the free session. Okay, one session we are open to everyone. All right, great. Then okay, so I look forward for the session next week. And okay, great set of questions today, and I look forward for similar kind of interaction in my upcoming classes. All right, thank you Saptrishi, thank you Nada, thank you Ramana. Okay, thank you Sundar, thank you Ali, thank you Batra, thank you Omkar, thank you Nitin, thank you Karthik, thank you Manjunath, Jitendra, Anup, Mohit, Sikh, Priya, Ted, Thomas, Mishra, Sapna. All right. Have a great week ahead. I look forward for the next session. All right. Bye-bye. Have a good day. All right. Yes, Sapna. Yes, go ahead, Sapna. Yeah, I will let you know about the yeah. So 8 p.m. India is something which we have decided, but let me see if we change the time. We'll communicate that. All right, we'll drop you an email with the timing. All right. Bye bye. Have a good day.